All right, we're ready for STAAR. Here's some algebra hot tips.
Hot tip number 1, use these 3. On the test, you'll be given a calculator, Desmos, and a chart of reference materials. Use them to check your math, check your answers, jog your memory, and test out ideas. This is what the testing window will look like when you take STAAR on the computer. Notice that there are buttons at the top where you can access the reference chart and calculator, and within the calculator window, you'll see the Desmos graphing calculator. Very, very helpful. And make sure that you ask your testing teacher for scratch paper, a reference chart on paper, and a calculator. The less things you have open on the screen, the easier it is going to be for you to see everything you need to see.
Now, hot tip number 2, you're going to see a lot of functions. They might come in different forms. You just should think y equals. And a function is only a relationship. It shows you that when you change x, y changes as a response. And again, we're going to think y equals for our functions. Keep in mind, a function has only one y value for each x value. So if I do the vertical line test, that should show me if I have more than one y value for any x. Oh, this one has 2 y values, not a function. Is this a function? Oh yeah, it only has one y value for each x value. This one? Nope. How about this one? Nope, that one has 3 y values. That's not a function. What about like this? If you see a table of the data, is this a function? Yes. But what about this one? No, not a function, because a function has only one y value for each x value. This function in red has 2 y values when x is at 2, not a function. All right, what if it asks you to plug a value in a function? This says f of 5. Well, we're just going to rewrite the equation, plugging in a 5 everywhere there was an x. And then calculate. 3 times 5 is 15. Add 10, 25. These are one of the easiest questions on the test. Plug and chug. All right, hot tip number 3. If you're given an equation, think y equals. Enter in the equation on your calculator or on Desmos, and then graph. You can get specific points by looking at a table. So again, you go to y equals, enter in the equation, put this up, hit second button, and then graph to see the table. Keep in mind that when you hit the blue second button, it gives you the second blue function above every key on your calculator. Oh, check it out. I see my x-intercept right there. Okay, so what point is this? The point where the line crosses the y-axis. We see this a lot. This is hot tip number 4. The y-intercept is asked about a lot. You can find it easily on your calculator by graphing the equation and hitting the button trace. Boop, and it'll land right on your y-intercept usually. Now what about this intercept? This is highlighting the point where your line is crossing the x-axis. Well, this is your x-intercept. This one is a little harder to find in the calculator, but if you go to the table, you should be able to find wherever your y value equals 0. That'll be right along the x-axis. Your x-intercept is going to come in very handy for solving later. All right, so now for our next tip, I want you to think about these kinds of equations. This is a quadratic equation. If we figure out what a, b, and c are, we can use the quadratic formula and do quite a bit of calculating. to get our answers that x can be -1 or +2. But there's an even easier way. If I take that same equation and I enter it in Desmos or my calculator, check it out. I find the very same answers looking at these points. These x-intercepts are my solutions. Wow, this took a lot less calculating. Again, all I had to do was enter in the equation and find the x-intercepts, the points where it crosses the x-axis. All right, hot tip number 6. Sometimes you'll be given a table of data and you're asked for an equation or an expression to represent that relationship. Where do you go? Oh, now it's time for the Stat button. Here's where you select Edit, enter in your x and y values, and then go back to Stat again to calculate with those values. So you're going to move over to Calculate and scroll down to where it tells you about types of regression lines you could make. Depending on your question, you might pick linear, quadratic, or exponential regression lines. You'll go down to Calculate. Again, that reg stands for regression. Hit Enter, and it gives you a parent equation with A, B, and C values to plug in. All right, hot tip number 7. So take a look at that chart that you get on the STAAR test. One great strategy, especially if you feel a little anxious before the test, is to do a brain dump. Just look over what it gives you, mark up a few things, draw a few things on it to remind yourself what's important that you've learned this year. And then hopefully by the end, you'll feel a little bit more confident and pay attention to those important things and remember what it gave you. So we've got 4 main things on our chart. We have a little bit about factoring, exponents, linear equations, and quadratic equations. So we're going to draw a little something for each. For factoring, I like the box because I think about how when you multiply those terms together, how you can organize it in the box and get it right every time. For exponents, I might pick an example where I plug in numbers for my a, m, and n to show how you get certain answers. For linear equations, I'm going to draw what a linear equation looks like, a nice straight line. And I'm probably going to put a star by the most important one on there, the slope-intercept form. Y equals mx plus b, we use a lot. That m is our slope, our b is our intercept, and this paper tells us what they mean. Next type of equation is our quadratic equation. Think about the U in the word quadratic. That's the shape of these graphs. They look like a U or an upside down U. And I'm definitely going to want to use that quadratic formula on there. Now, there is one type of equation that's missing. We learned about it last this year, and that was exponential equations. This is where we saw exponential growth or exponential decay. So I would go and write this for myself before I started the test. I would say y equals a times b to the x, where a is the starting amount and b is either the growth or decay factor. And notice that it's raised to the power of x. That's why it's exponential, right? The power of x is an exponent. All right, hopefully after you do your brain dump, you'll feel confident and ready. All right, hot tip number 8. These equations on the chart, keep in mind that most of the letters we're going to replace with numbers. So the A, B, and C, M, H, and K, we're all going to replace with numbers. We'll keep X and Y usually in place. And you can figure out what's what by what they're multiplied by. Take a look at this one. We have -3x plus 5. I can tell that -3 is my m because it's multiplied by x. And I could tell that 5 is my b because it's a number with nothing multiplied. No variable multiplied by it. All right, what about this one? If I look at a quadratic equation in standard form, I can figure out a, b, and c looking at what's multiplied by it. So a is multiplied by x squared, so that's got to be my 6. B is multiplied by x, so that's going to be my 4. And C is just a number. That's going to be my -9. And once I have my A, B, and C, well, then I can plug it in the quadratic formula. All right, hot tip number 9. Some questions ask you for an equivalent. Did you know you can enter them all in Desmos and then just find which matches? It saves you and is more accurate sometimes than working out all the options. So here, take a look. I've entered in the equation in the question, and then I enter in all of the answer choices. And then all I have to do is find which graph matches. Oh, that's the one. That one looks like it has the same vertex, and it looks like it's crossing the x-axis in the same points. So I like answer choice G for this. You could also do this on your calculator if for some reason you're not using Desmos well or something's wrong. You can enter it in on your y equals, with the question being your y1 and your answer choices being entered as other y values. And you can even look at a table view and find which values match exactly, right? So in this one, I see that my y3 is the one that matches my original equation, and so that's how I can find my answer. Just keep in mind that when we're entering it on the y equals screen, we're going to enter in x's instead of other variables like n. All right, now for our next tip, I want you to think about what is a graph. All it is a visual for your data, and it shows you patterns and relationships. So if you look at this graph of y equals x minus 1, it shows you all the combinations of x and y where y equals x minus 1, right? Where all the places where it's true. So that includes where x is 0, y would be -1. So let's enter this example where x is 1 and y equals 0. Does this hold true? Is 1 minus 1 equal to 0? Oh yeah, definitely. So think about how a line shows you all the combinations of x and y that are true for that statement. Okay, now for the hot tip, number 8. If you're given two equations, that's called a system of equations. Oh, I know you know what that looks like. And you're supposed to solve for x and y. How do you do that? Well, one good technique is to get both of your equations in y equals form. And then you can graph both equations. And remember, a graph represents all your possible solutions. So where would be a solution to both equations? Bum-ba-da-da, where they intersect. So the solution is this point, -3, -4, and those are my answers for x and y. And if I plug those back into my equations, okay, let's see, y equals x minus 1. Does -3 minus 1 equal -4? Yup. These answers should work for both equations.
In the last example, an important first step was putting the equation in y equals form, or to solve for y. When you do that, be careful about combining only like terms. Check out the video links in the description for a quick refresher on solving equations.
All right, for hot tip number 9, a lot of people get confused about domain and range. So I like to think about all my x's living in Texas in a special place called the domain. So when I'm asked what my domain is for a graph like this one, I'm going to think about all the possible x values of the equation or of that line or line segment, whatever it may be. I'm going to look on the x-axis and see, okay, so my lowest x value starts at 1 and my highest goes all the way to 7. So my domain is between 1 and 7. So I'll say x is greater than or equal to 1 and less than or equal to 7. I use the or equal to because these are closed endpoints. Now what about my range? Well, now I'm going to look at my y values, starting at my lowest y value all the way up to my highest y value. And I see that it's all between 2 and 5. All right, try this one. This was a graph of a quadratic equation. What was the domain? These don't have endpoints, do they? They have arrows that show that it keeps going up and up and up and out and out and out forever. It goes on to infinity in the negative direction and in the positive direction if we're talking about all my x values. So what's my domain? All real numbers. Now what about range? Okay, so this one, it does keep going up and up and up forever, but there's a minimum, right? The lowest possible y value is right at -6. So my range is going to be y is greater than or equal to -6. All right, last hot tip number 10 is how do you convert a percent to a decimal? Well, if you think about cent and what it means, think about cents in a dollar, 100. Years in a century, 100. Cent means 100. So percent is out of 100, and you can calculate it dividing by 100. So look at the example on the calculator screen. They want 4%. It's 4 divided by 100, bing, 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 0.04 as a decimal. And the other example, if they say 2.9%, we're going to divide that by 100, and that'll give us the decimal 0.029. And we'll get it right every time.
And here's one place that converting percent to a decimal will come in handy. When we learned about exponential equations, one thing we learned was if you had a population growth of 11% per year, you could use this formula, but you need to convert that 11% to a decimal form. Now keep in mind this formula is not going to be on your STAAR reference chart, so it's a good one to remember. You start with your initial amount and multiply it times 1 plus or minus the rate of increase and raise that to the power of the time periods.
All right, use your time, use your tools. You've got this. Let's go Raiders.